Outspoken Engineer podcast. We've sat down with some manufacturers the last few months. We've sat down with some heat pump experts. Now we're sitting down with someone that's heavily involved with heat pumps. We could call him the expert. We call him an enthusiast. But he is actually involved with an energy company, Octopus Energy. Today I'm sitting down with TJ Root. He is the Heat Flexibility Director at Octopus Energy. Lovely to meet you, TJ.
Thanks for having me.
Thank you so much for coming down here. We originally reached out to you because we've sat down with manufacturers, we've sat down with people heavily involved with heat pumps. There's a lot of positivity around the heat pump space at the moment, and there's still massively, skepticism there. Coming from a HVAC background, I own and manage a relatively large air conditioning company. I've still on a fence with a lot of ideas and the thought of everyone having heat pumps. So Octopus seem to be growing substantially in a space which we would call the aircon space, and you seem to be doing things slightly different to the manufacturers. So we come across you. You're obviously doing very good things yourself personally, maybe in a leadership stance. But then
I like to think I'm doing good things personally.
And also, our conversation earlier, you're actually relatively did you have to learn the technical side of heat pumps? Because you seem to know what you're talking about.
Once upon a time, I studied mechanical engineering. So I guess you could put me in the category of knowing enough to be dangerous at this point, having never worked as a practicing engineer. But I like to think I've retained a decent amount of the knowledge.
Okay, so your background into heat pumps, and also your personal journey. So it was actually quite difficult to get some research out of you. We put in TJ Root, Octopus Energy, and Google, and have you got a military background?
I do, yeah.
So what's your background? You're from the States.
I am. Yep, I am American, which I think is probably no mystery given the accent. But I served in the U.S. Army for a number of years, longer than I will admit on air. But I was,
okay.
Yeah, I primarily I was a helicopter pilot. I flew in the Air Cavalry. And after a few years of doing that, I transitioned to special operations, and I did that for the remainder of my time, flying some different aircraft.
Wow, okay.
And so did that, and at one point I decided I'd had enough of that type of adventure, so I got a little bit more education by way of business school, and as life often goes, a bit unplanned or sort of unexpectedly ended up moving to London for a job that was not with Octopus.
Okay.
I worked in consulting before this.
What type of consulting?
I worked in strategy consulting, but most of my work was around industrial goods, energy, and some financial services.
Okay, so did you stumble into the heat pump sort of industry, or was it a space where you sort of could, was it I applied for a job and I took on this great big challenge, or was it, was there a heat pump, sustainable element where you were like, I'd like to get into that space?
I don't think it was a particular draw to heat pumps initially, as many folks do. I had done several years in consulting and decided I wanted something that felt both a bit more sane and a bit more tangible, I suppose, that you sort of can make your mark on and be part of a long-term growing business and solution. So I was looking around, and I knew some folks who work at Octopus just on the personal side, and reached out through them and got introduced to the gentleman I work for now. And Octopus had just started in the heat pump space, and he asked me, do you know anything about heat pumps? I said, well, I owned a heat pump because I had a heat pump for about 10 years in a house that I lived in the States. And so I was quite familiar with them. And, I've kind of thinking back to those thermodynamics classes of, the ideal air conditioning cycle, and think, I remember how these work. But, as we talked about it was very clear, this is a very interesting space. A, it's a growth space. B, it is really fundamental to net zero and reducing the impact of our day-to-day lives on the climate on a really big scale. And I think it's fun to take on a big problem.
Your heat pump journey. So we've got a few friends in America in the HVAC space. And what part of the States are you from?
I grew up in Ohio.
Ohio. Where is that on the state map?
Uh,
Is it like, I feel like it's towards like the middle left. Is that right? Or
middle right. It's sort
it's
of
middle right. Okay.
yeah. So it's sort of was part of the sort of first frontier after the colonies. You get over the Appalachian Mountains, and then you're into sort of what we consider the Midwest. It's right. It's in the Great Lakes region.
Is it anywhere near Virginia?
Well, it's about an 8-hour drive, so I think for Americans, we're like, yeah, that's kind of near. In the UK, that
For us, it's
probably
very,
doesn't qualify
very,
as near.
very far.
But I was funny enough. I was actually born in Virginia, and we lived there for a number of years before we moved to Ohio.
So one thing we know with the states is every state is so different. And when we talk heat pumps, some states at the moment there's massive drives for better refrigerants and better heat pumps, whereas others are still quite, I'm quite happy with my gas furnace. What was your heat pump journey like in the States? Was it electric, or was it an air conditioning system with a gas furnace bolted to it?
No, it was a fully electrified home. So it was a heat pump air conditioning unit.
Yes.
With a reversing valve in it, and so
did that do like a central duct system in the house?
Correct. Yep.
Okay, so you actually had a really good, your experience was actually. You could take that into where you are now because they work.
Yeah, exactly. I mean, it was funny coming into the heat pump space. It was something I had never really thought about, even though I'd had one for so long, because it just worked. When in the summer there was a switch on the thermostat, you switch it to cool, and you'd have nice air conditioning all summer. And then there's that point in the fall where you decide that it's finally cold enough outside that you probably want to turn the heat on. And you flip it to heat, and then you have heat all winter. And
so you had what I love is, and that's what we do, is an air-to-air heat pump.
Yeah.
Great air-to-air heat pump. What
Correct.
did you do in the States for hot water? Was it just an electrical cylinder?
Yeah, it was an electric cylinder.
Okay. And again...
Which is very common in the States to have a system that is split where the cylinder has its own heating element in it.
They're not very efficient, but energy in America was probably a lot cheaper then.
Yeah,
It probably is still relatively
Yeah, it
cheaper.
is still relatively cheaper than the UK. And it was quite cheap then. And it is, as you said, every state is different, and even within states, there's very different regional pricing. Where I lived, we happened to be on. It was a vertically integrated company, but it was an electric co-op, and a lot of the electricity they generated was hydroelectric because we live near a river, and so the co-op, the purpose is not for them to make profit, but to just keep the enterprise running. So electricity was pretty cheap.
Gotcha. One thing I just want to pick up on, because some may want to know the answer, but I do. Being a helicopter pilot in the US Army, do you have to have like insane vision? And I think somebody once told us that you have to be able to look with your left eye and look to your right eye in different. Or if that's like a Black Hawk pilot, have you?
Well, what they were probably talking about there was Apache pilots. When there's a system. Which it may be called something else now, but in my day, I'll say it was called the PINVIS, the Pilot Night Vision System.
Okay.
And Apache pilots they'll call it flying the bag. But yeah, they had a single monocle that would show the thermal view of the outside, and so they're kind of flying with one eye while using the other eye, to look around the cockpit. I mean, so your eyes are still, they're aligned. You're not splitting.
Have you got a party trick where you can do that, like split your eyes?
No, I don't. I was not an Apache pilot, but no. I mean, I guess insane vision is probably not right. As I recall, when I went through the medical screening, it was you had to be 20/50 or better, and it had to be correctable to 20/20 with glasses, basically. So you could have maybe an astigmatism or something that would make it not fully correctable. That would disqualify you. But
gotcha.
I think now they've fully approved all of the corrective eye surgery. So I think the vision is not nearly the hurdle it was.
There's probably a lot more tech now in them helicopters as well, right?
Yeah, it's not a lot that affects your eyes, though.
The days of holding a gyro are probably slowly going, right?
No, I mean you still flying the same way. A lot of them have gone to digital flight controls now.
Okay.
So they're especially in larger aircraft, you will have a lot more control authority and some greater stability assistance from the system itself, but that requires, it's typically on larger aircraft where you have the servo electronics and you also have a very robust hydraulic system. The helicopter I spent most of my time flying had no hydraulics, so it was all
What,
just
cable?
mechanical
All
controls.
mechanicals?
Yeah, it's all mechanical.
What was the helicopter?
It was called the MH6.
Okay.
Little Bird. Yeah.
Is it still being used?
Yeah, absolutely.
Oh wow, okay. Is this one of these helicopters just for, interest? Is this the sort of helicopter you'd see like in Is it Forrest Gump? I think.
No.
I think it's like the stereotypical like army plane they've used in film.
No, that would
army
be,
helicopter
that would
they've
be
used
the
in
old
films.
Huey. No, if you want to see that helicopter, or the one that I flew, watch Black Hawk Down. The small ones in Black Hawk Down.
Really?
Yep.
Oh wow, interesting. Okay. Well, we can probably put a picture of the helicopter in this podcast just so you can see what TJ has been flying in the US Army.
Yeah, once upon a time.
Right. Okay. Let's talk about Octopus. So, how long have you been at Octopus?
About 2 years now.
You've been at 2 years. So, from day dot to probably now, have things moved at a substantial rate? Have things changed significantly?
I mean, I think things change week to week. It's probably a bit of a cliche to say, you're a fast-growing, fast-moving company, because a lot of people say that, and a lot of companies are. But I would say the change has been monumental from a time when I joined, when our heat pump business was really nascent. I mean, incredibly small, to now selling and installing hundreds per week across the UK. I mean, that growth over the 2 years has been phenomenal.
And when you started, did you have the figures for how much were being installed per month?
By Octopus?
Yeah.
Oh, gosh. I mean, it was probably under 50 per month.
Wow.
Yeah.
And now you're doing substantially more.
Yeah, definitely. Definitely more.
So us doing some research, and it's quite clear out there that Octopus seems to have like sort of three products. They have their Cosy 6, they have a Cosy 10, and they do use the Dakinau Therma. How long have you had the Cosy 6?
The Cosy 6, I mean, was in development for quite a long time. We first started installing them for customers in June.
Okay.
And so it's been out sort of, in the wild for about 6 months now.
The Cosy 6, you acquired a company called Red?
Yep, we did.
And that's, I see as Octopus probably looking long term, and also going all in. So there's a lot of confidence there, saying, if you look at there are some old videos online of the owner of Red, and he obviously looked at designing a heat pump which was very different to an aircon unit. And in the aircon space, we almost have the questions that the heat pump companies have. Why is everything cream? Why is everything long and rectangular? Why is it like this? Why could you buy an aircon unit in the 80s and the condenser is the same shape?
Right.
So in the heat pump space, it seems like people have put money and investment into developing different shapes with an angle of being better and making things better and more user friendly. And the Red heat pump seems to be, I think when it was probably first developed, it had a similarity to the American, what we call the dustbin units.
Yeah. Which have not changed shape. I mean, definitely since I was a kid, they still look exactly the same.
But the Red heat pump, the gentleman that I would have thought maybe it was just like version 1 or 2. It was very easy to maintain. Panels come off, and I watched the video and was like, yeah, smart. So Octopus have then stepped in and probably developed that product further. Is that how the Cosy 6 has come about?
Yeah, essentially. So you take the technology and all the learning from the original Red units, which were a very different shape, right? You can probably still find one without much difficulty in the wild. There's some around the UK and in Ireland. They were cylindrical and tall. They almost looked like a kind of a jet engine turned on its end.
Yeah.
So the shape, obviously, of the Cosy 6 is fundamentally different than that, but a lot of the same principles from that were baked into the Cosy 6.
I see. So the Cosy 6, I personally don't think there's anything out there like it that looks like it. Maybe I'm wrong, and maybe you've got a lot more R&D.
No, I don't think so.
But it almost looks like the game Pac-Man.
Yeah.
And you've got the let's call them the baddies.
Yeah, the ghosts.
It almost looks like the ghosts with a fan on a certain angle. So I kind of feel like looking at that fan being at a certain angle is a design. It's been designed at that angle.
Correct.
And also, me just being an engineer, there's no water sitting on the top of that unit. It'll drip off.
Correct.
It looks quite easy to lift up, because there is nothing worse than carrying a 10 kilowatt heat pump, which is massively rectangular. I would have thought there's a design. You've looked at the design for carrying it, positioning it, maybe access. And I've not seen one in pieces, but looking at the Cosy 6, it almost looks like you might have a couple of screws at the bottom or bolts, and the whole lid lifts off. Is that almost
Yeah, well, you wouldn't take the top off. So if you were to look at the Cozy, there are two screws at the front that hold the door on, and that sort of whole lower third below the fan comes off, and that's where all of the major components are, with the exception of the fan and the evaporator, which are obviously above that. But yeah, the unit itself is basically, from a structural standpoint, is sort of 3 or 4 main components that go together in a bit of a modular fashion, which then informs designs that follow on.
So how because the old red unit, the gentleman that developed it, he kind of made, which I really liked watching the video, he made it quite clear that this side is the electronic box. You don't really want to go in there. And then you've got what he called the important bits, the circulatory pump and all the mechanical connections. Have you retained that in the Cosy 6?
Yeah, essentially so if you were to open it up, you would see you have your refrigerant circuit and your water circuit and your circulating pump and receiver and compressor on one side, and then you have sort of a vertical divider and your plate heat exchangers over there for your condenser, and then all of your electronics are on the other side of this of a vertical divider there, and they are contained within a splash guard for obviously ingress protection. But yeah, you sort of put everything, the inverter drive and all of your circuit boards, it's all self-contained. Yeah.
So that so for those out there that are engineers, or your aircon engineers, one thing you'd know is if you look at an air-to-water heat pump or an air-to-air heat pump, you take that side panel off, and it's there's a lot of PCB boards on show. There's a lot of everything on show, and it is a bit of a minefield. So your product is actually a complete different design to the conventional heat pump.
Yeah, I mean, I think from a sort of visual perspective, when you take it off, you're not going to see all the PCBs because they are behind that splash guard, because you obviously want to keep them, warm and dry for the entirety of their lifespan. And so, yeah, when you open it up, you would not see all of those things that when you open up a more traditional heat pump or an older design, as you say, a lot of the sort of circuitry and electrical connections will be quite exposed.
Okay, so with the Cosy 6 and the Cosy 10, what else went into the development? Was it, I've got a heat pump at home. It's a Samsung. We inherited it, but the Cosy 6, is it? It almost looks keep it simple, stupid. Was that what fundamentals went into the design to make it better than it originally was? I know we've gone through shape and visuals and accessibility, but was it? Did you want an easier way to just monitor energy consumption and say this is how much the heat pump, the COP is and the SCOP, and this is the way we do it? Are you trying to simplify things, or are there other design criteria that I'm missing?
Well, I think, I would start with the concept of installability. As you mentioned, it is easier to carry. It is easier for a small crew to install. It's easier to actually connect.
Okay.
The plumbing connections are quite easily accessed and located, and the wiring it's a simple case of pulling 2 wires through the wiring tunnel and connect them. Your power supply and your Modbus control.
Oh wow!
So the essence of that is how do you install this easily with a smaller group of people, which is one of your biggest levers for getting that cost down. On the control side, we've designed our own controls for it.
Okay.
So we have the Cosy Hub and we have the Cosy Pods. And the pods, to start with them, serve as temperature and humidity sensors in different rooms within a heating zone. Nice. One of them provides the primary control signal to the hub. The hub then is sort of your, the brains of the heat pump, giving you the signal to for space heating and for hot water, and all of that is controlled through the Octopus app. So instead of having to, access your thermostat on the wall in a physical location, you and your loved ones or whoever else is in the home can have the Octopus app with the account and can set the heating, which for the dads out there might be a bit of a nightmare if your kid's changing the thermostat,
of course.
Right?
Yeah, well,
I think we all grew up with a dad who guarded the thermostat.
That's down to the family to give access.
Yeah,
to the
exactly. So there's probably some dads out there who will hold on to that tightly. But yeah, the goal was to simplify it and make it accessible. We know that everybody carries a screen in their pocket now. We don't need this expensive physical screen on the wall that you have to go over to and change and try to set up a schedule in that thermostat. If you've ever set it up like in a one of the smart thermostats, you try to do it on the wall, it's very difficult. And so you end up using the app anyway. Well, if the app is that much easier that you end up doing it through the app, then that should probably be the primary control. And that gives you a lot of power to affect your heating when you're not at home, or from the comfort of your bed, rather than turning the heat up or down by getting out of bed. You can just do it on your phone, which you're pretty much always going to have with you, in sort of modern life.
Okay. So with your app, with your control system, with the Cosy 6, you're obviously trying to roll this out in a mass scale because you're obviously growing. As engineers, I know heat pump engineers are still relatively new. We could have a conversation all day about how do we get more heat pump engineers in there and in the market, etc., etc. Making them adopt them is a different thing altogether. So your Cosy 6 and Cosy 10 is a new product. So you've almost got two battles here. You've got to get the heat pump engineers, and you've got them to win over putting in your Cosy 6, Cosy and Cosy 10s. Am I right in saying that if you want a Cosy 6 or Cosy 10, you have to go through Octopus and you have to use an Octopus engineer?
Correct. At the moment, that is the only way to get a Cosy 6 or the forthcoming Cosy 10. We employ our own installers.
Okay.
So when you get an Octopus heat pump, you will have Octopus vans turn up at your home. It will be Octopus lead installers and plumbers and electricians who do the work.
And they've worked on the Cosy 6 and Cosy 10. They're trained on the Cosy 6 and Cosy 10. So any problems you have with the units, nothing is perfect. They're common across the scale, or any questions or any challenges or any, user questions, you've almost got the answers because you're used to the same product.
Correct. As we've rolled these out, obviously we have trained our workforce, which was substantially large to begin with, and have now trained them on the new equipment, and they're doing more and more installs every week. And so, you build that knowledge base. And then we have a separate set of engineers who only perform aftercare functions. So their whole job is to go out and do any repairs or changes or updates that are needed on the units. And so we train them very specifically to have that depth of technical knowledge. Obviously they could do an install themselves, but they can also do that sort of next level of troubleshooting if there were to be an issue that required some more technical insight.
So with your aftercare, so with us, for example, as a business, we tend to stick with 2 or 3 brands. The leading 2, Daikin and Mitsubishi in the aircon space, and we do have a third alternative. And there's always various reasons why we put them in. And we speak to so many aircon companies and people always say their product is more efficient, their product is this. We personally push certain products because the product is only one thing. After service and customer service, aftercare, technical support, I actually think that's more important than the product. Personally, you could have the most efficient air conditioning unit on your wall, but if there is a noise or something is not right and you can't get the answer from the technical department or the after sales, which, believe it or not, is big, it puts you off. And then what tends to happen is, which we've seen in the heat pump game, speaking to heat pump installers new, what heat pump should I put in? There are so many options. Do I put in the Valent? Do I put in the Nibi? Do I put in the Daikin? Do I put in the Mitsi? My advice always is, pick 1 or 2, get familiar with it, be your own after service or your own aftercare. It doesn't need to be the most efficient. So at Octopus Energy, with their, obviously your Cosy range and your Daikin range, are you trying to sell your heat pumps as we are the most efficient heat pumps out there and we've got okay customer service? Or are you conservative with your figures and you've got the supporting infrastructure to say, if you want an air to water heat pump, we've got the tariff, we can do this, we can do that. This is what we think you can get. This is probably the worst case scenario.
Yeah, I think that is a very good description of our approach to the heat pump space in general, which is, 1, take a conservative view on efficiency. As you said, the heat pump is one element in terms of the equipment, as a purchase, but it's also just one element of a system in a home. And there's so much variability between homes and also how different families live in potentially the same home that the SCOP or the COP of your system at any given point can vary quite widely between homes. And so when we talk to customers about the efficiency of their heating system, we take a deliberately conservative view.
Okay.
And that's because we prioritize the customer experience and that customer trust in us over pretty much anything else in our commercial endeavors. And so what we would never want is to sell marginally more heat pumps by promising this higher efficiency out the gate, only to have those customers come back and say, I think you didn't give me a good deal. I'm not seeing the efficiency you promised. So instead we take that view of, we're going to kind of give you a lower view on what the potential efficiency would be in order for you to make those comparisons on cost, and then include the effects of the tariff, like our Cozy Octopus time of use tariff,
see.
and how that would affect the overall ownership. When in fact you are quite likely to get a higher efficiency than that, but we always want to make sure that the customer feels like they knew from the beginning, sort of maybe not the worst case, but a much more conservative case on what the ownership experience will be like, and then be happily surprised rather than be unexpectedly disappointed.
So personally, not just because you are here from Octopus Energy, I love that approach personally, because in the heat pump space, you could spend hours on LinkedIn. We've seen some conversations, people posting scops and cops of 6 and design is wrong, and there's certain ways of doing this, doing that, and then what that does is it's a bit like the budget that's just happened in the UK, where people, indecisiveness and the unknown is actually more of a problem than the truth, rather than just letting them have it. So if you are a bit more conservative and you're saying this is kind of what you're going to get, and you know it from the start, you're a lot more comfortable, because then when people are saying we're getting cops out of our unit at 5 or 6, you've almost got the attitude of, we get 3 to 4 with our Cosy, and we've got a really good rate, and we know what it's going to be every month, rather than you telling me that your unit is 400% efficient. You put it in, but what you don't understand is my radiators have been plumbed in, with the wrong size pipe, and that's causing an issue with the the cop and the scop, and then I've got a bad taste in my mouth, and that's what's happened in the heat pump. That's what's been happening, where the heat pumps don't work. The heat pumps, I've been missold, or my energy bills have gone for the roof, etc., etc. And it's because they've been sold a bit of equipment, which, yes, has got the best inverter technology with the best compressor. However, it hasn't done what it said on the tin because of other factors.
Right. I mean, trust is built over years and lost in a moment. And that, of course, applies to heat pumps, but also to everything else in business and our personal relationships 100%. As well. I liken it to when you go to purchase a car, the old sort of, internal combustion buying experience of, there will be a quoted mile per gallon highway and city on the window sticker. And very few of us ever experience that
for sure
sort of efficiency, right? That's done in a perfect environment and laboratory test. So sure, if you go on the MCS database or commercial websites about heat pumps, you will see some great numbers for SCOPs. This heat pump can do a SCOP of 4.9 or 4.5 or what have you. And will you experience that in your home? Maybe. Probably not, because as you said, there are so many other factors, right? Being able to get those numbers in a sort of perfect laboratory condition versus in your home with your plumbing system and your radiators and the way you run your heating and where you live and the weather and the insulation. There's so many other factors that go into it. It's, I think, really important to view the heat pump as a system, right? It's not a heat pump, it's a heating system. And to give customers that very realistic view with, some sort of buffer in terms of expectations.
Yeah, of course.
So people go into it with clear eyes and understand what they're buying. And again, we'd like to see them be happily surprised at the efficiency and the savings.
Nice. And your after support. So you've got your own in-house engineers.
Correct.
Are you doing things differently to the others? You've obviously got in-house aftercare teams, customer service. I don't know, have you got any in-house training things? I know some manufacturers, they say you have to answer the phone within 10 rings. Have you got anything like that as such?
Well, I mean, I think we have really set a very good standard in terms of our responsiveness to customers as a business, right? It's something that we are known for, that typically we answer the phone within minutes, or we answer the phone instantly, and then your wait time is single-digit minutes.
For sure.
Even when we're incredibly busy, to talk to one of our energy specialists.
For sure.
When you contact aftercare, you can call us, you can email us. Sometimes we have people, will send me a direct message on Twitter or X or whatever we call it now, saying I have a problem.
Okay.
The one thing we always tell customers is, please just reach out to us. Phone, email, carrier pigeon, however you get a hold of us, we will come and support you. The only time that we can't make it right for customers, if you'll see people will go into different sort of social media forums and say, I think my system isn't working right. I'm unhappy with this.
Sure.
And then if we don't know about that, we can't support them and go out and give them the fix that they need, or make the adjustments that might be needed. So as long as the customer contacts us, I'm really proud of how responsive we are, getting people out there, days, nights, weekends.
All right, okay, interesting. Your product itself, using the Cosy 6 and Cosy 10, because I know a lot of people in the heat pump space, they're all heat pump experts. I'd say 5 out of 10 heat pump, homeowners have made decisions based on YouTube videos, Googling, and efficiency. A lot of people have solar panels, and a lot of people like to use third party, like, I don't know, Mixergy cylinders and things like that. Are your products compatible with others, or can they work alongside them? Or is your approach, we stay away from, we just, our units, our cylinders, etc., etc.?
For now, we install, when you buy from us, you buy the system. And so we offer a slate of cylinders that are compatible with the Cosy. If a customer has other technology that they have bought themselves or is existing in the home that we think can work with the system, we will typically try to incorporate that into an installation. But we do not sell those sort of more bespoke technologies, whether it's, an Eddy or a Mixergy cylinder, as part of our install. But we're always willing to work with customers to try to make their ultimate desire for their system a reality.
For sure. Okay. The Cosy 6 and Cosy 10. So, for those technical, because you're not probably going to tell us the ins and outs of the parts used, but they're inverter compressors.
They are.
The fans, are they? I take it they're like an EC fan, which is modulated from a control board, so it's not a fixed speed fan.
Correct.
It'll ramp up and down. Okay. What refrigerant is it on? Is it R30?
R290.
Oh, it is on propane.
Yeah, they're R290.
Nice. So for you, very active about GWP. I think it's got a GWP of 3.
3, yep.
And rumours have it might be being devalued to 2, which we've recently heard.
Oh, well, I hadn't heard that, but that's great news, right? I mean,
so you're on R2. Was it always on R290?
Correct, yeah. Yeah, it was designed for R290 from the start.
So on that basis, I think your heat pump is the 6 and the 10. There's probably going to be no changes unless you have a niggle or something wrong with a product a part in there. That's going to be the latest model for the next few years, one would have thought, being on R290.
Yeah, I mean, there will always be continuous improvements to the model. You will see probably over the next few years some slight visual changes to it as we improve the design. Right? You're always learning from your experience of building it, but also how customers interact with it and how it works in the field. So, we would never just stick with sort of the first model. But yeah, I think the guts of it, if you will, right? Sort of the heart of the unit. Yeah, having gone to R290, which is again, low GWP, it conforms with all of the new EU F-gas standards, even though we are not in the EU now. That part is not going to change, right? So we will be making marginal improvements and continually doing so, but yeah, the fundamentals of the heat pump will stay the same.
Well, with R290, some know about this, some don't, and it's great that you're conservative with your COP and SCOP figures, because the lower the GWP, the less efficient the units become. So an R32 heat pump is marginally more efficient than an R290 heat pump, but you've got a GWP of 675 versus 3. So if you're being conservative with your 3s and your 3.5s, and even maybe even you say 4s, it's going to be like that for some time. So it's not like...
Yeah, there is a bit of a mentality shift around what those numbers are going to look like for people when they see. And sometimes people will compare and say, well, this heat pump has a higher SCOP than that heat pump. Well, sure, if one is R290 and one is R32, there's going to be a bit of difference there. And there's a lot of difference between the refrigerants in terms of how they perform in different temperature ranges. Again, the sort of
R290
environmental efficiency of them.
One of the things which might come into your space is definitely going to come to the aircon space and especially the heat pump chiller space is the next thing which we believe that is going to be next after GWP is PFAS. I don't know if you've come across PFAS. So PFAS is forever chemicals. So you see the microplastics and working. So, when I was on the tools, it was R22, R407C, and the tail end of 410A. Right. But a lot of them refrigerants are really high in PFAS. So I don't know, maybe I'm 20% R22. I don't know. There's a lot of it in me somewhere. PFAS is next. But R290 has got a really low PFAS number, and the only way of getting lower is CO2.
Right. I mean, it's a natural refrigerant, right? That is one of the benefits of it, is that it is a naturally occurring molecule versus something that man has synthetically created. Yeah.
Correct. 3 parts. So R32 is a blend. and there is actually small elements of R32, which is actually high in GWP, but it's called a link molecule. It's all new to us, but R290 is a completely different family.
Yeah.
So it's a refrigerant which, in the air-to-air space, so now all the air conditioning units, starting from, again, it's all silent at the moment, from sort of mid next year, they're all going from R32 to R290. So what's really interesting is almost as if, which is bananas for me to say, the heat pump companies, the manufacturers, you're actually almost ahead of the game with the aircon because you've actually led that.
Yeah.
Because you're mass adopted. Obviously, the downside is it's a propane and it's flammable. But the good thing is with heat pumps, you're outside, you're not inside the home.
Correct. Yeah, you're outside, and it's a very small charge of propane in a unit, right? You're talking about 500 to 600 grams in a small heat pump, which is nothing, right? I mean, it is, and it is interesting. I think when there was the shift to R290 in the heat pump space, there was initially some concern about it's flammable
For sure.
refrigerant, but of course with a monoblock unit, it's not entering the home, and there was, I think, a lot of question around what will the rules be about this, or what will the safety be around this. And you think about the fact that there was so much concern about that, but I can also go down to the garden center and come home with a 13-kilogram bottle of propane and set it right next to my home. And all of us do that all summer long.
Of course.
And then open the taps on it and light it on fire to make our steaks and our hamburgers.
Well,
it's really not a concern.
The joke in aircon is when we go R290, you can charge a system, and if you're a bit hungry and cold, you could use R290 to light up your stove.
Yeah.
But yeah, don't do that. We don't recommend that. But yeah, that's the thing with R290. So so Octopus's vision, in 2 years' time, have you got any? I don't know. Is there an itch for the commercial space? Is there a potential to get into 25 to 50 kilowatt heat pumps, or is it purely we are serving? Because I don't take this as an insult, but you are the new British Gas of the heat pump world. Okay, British Gas, I think they're probably a rival of yours, but if you went back 10 years ago, the biggest gas company in the UK was British Gas. Are you focusing on just the home market? Is there any itches for the commercial, or is that something which you won't tell me if you were?
Well, I mean,
Are your products? Is your Cosy 6 going to be a Cosy 30?
I don't know. I don't know if we'd go to a Cosy 30. I think you'd probably at that scale you're looking at a fundamentally different architecture of unit. But I think to take the commercial space more broadly, I will sort of take a pass on the hardware side of it in terms of whether we would get into that. But from a heating space in general, or heating question in general around the commercial space, what we think about in terms of heating is the carbon impact, right? This is a huge source of carbon emissions and demand on the grid. So if you have, the commercial space is proportionally higher in electrified heating already. Most of your commercial office buildings have some form of electrified heating or cooling in them.
With aircon. But the thing is with commercial,
I
don't know if you know the figures, but I think it's 60% of, it's either 60 or 40, but 60% of gas emissions in the UK is caused by commercial buildings. So my argument has always been with, leave the residential owners alone, leave them on gas. My argument's always been, well, it's a lot easier to target the commercial buildings than it is the residential homeowners because it's 60% of the market.
Yeah, I mean, I don't think, it's 60% of the market, yes. It's also not 40% of the market, right? So in terms of getting to our net zero and climate goals, you still have to be in the residential space. And that is where we started as a residential or a consumer retail energy provider. From the, putting sort of my heat flexibility hat on, there is so much opportunity to reduce demand on the grid and reduce carbon impact by electrifying the commercial space, regardless of who makes the hardware.
Yeah, for sure.
And then deploying that electrified heating in a way that is optimized to reduce strain on the grid, to provide flexibility services to the grid with turn up, turn down on the demand side. It is a huge opportunity space. So, I would like to say we will do something there. The hardware question.
Because you're an energy company.
Correct. We're fundamentally an energy company.
This is what's so interesting. So, speaking to Mr. Graham Hendro, which I call Mr. Heat Pumps, I sort of said to him, well, you'll never adopt this if you can't. My figure was £5,000. So if you can get a heat pump installation in your house for £5,000, I think it makes it really attractive. I don't know how much Octopus charge. I don't know how much your rivals charge, but we've always seen sort of a £10,000 to £15,000 install with your bus grant. Has your Cosy 6 and Cosy 10 allowed you to reduce your installation costs?
Yeah, so we are reducing our installation costs, and I would even challenge that and say probably £5,000 is too much. You need to be really in the 3,500 to 4,000 pound space to be at parity with the boiler, right?
Wow.
The thing with heating systems is, I find heating systems really exciting and fun. You probably feel similarly, maybe from an air conditioning angle. The average person does not find those to be really exciting, fun.
Well, we're jazzing it up right now.
Right.
It's not. Yes, of course.
And I can tell you from my experiences at parties, and and even on some dates, that going deep into the heat pump discussion is maybe not the most exciting topic area for a lot of people. And so I say that because that means fundamentally people are going to buy on price. You have to be at parity with the boiler, so the decision is so easy. Why would I get a boiler if I can get a heat pump for the same price? It's more efficient, it's greener, it lasts longer. But ultimately, we're asking people to shell out a big chunk of money for something that, in an ideal world, the experience will be the same. Your home will get warm when you want it to be warm, and that's it. Right? If we get the heat pump space really right, there's almost no difference in experience between the boiler and the heat pump. And so you can't really have a significantly higher price. And so our goal is to get that price down at parity with the boiler.
Wow.
And so most of our installs now range between 4,000 and 5,000 pounds, but that's including the effect of the bus grant. And so we have to get the price down to that boiler parity without the bus grant being there to sort of give us that boost, to give us parity with heat pumps or with boilers. It's great to have it now, but we can't build a market around that because it will not be there forever.
I'm going to make the assumption that that'll only happen with your product.
Well, that is one of the fundamental reasons we have built the product. The goal is to get the cost down as low as possible.
Wow.
And again,
that's almost like a market disruptor, what you've done there. And the reason I say that is if you look at a cost of a 5 kilowatt heat pump 5 years ago, it was probably about £1,200. Now it's probably 3 times the price. And one could ask the manufacturers, why have the materials gone up that much and has the transportation cost gone that much? And the answer is no. It's making hay while the sun is shining.
Yeah.
So you've stepped in almost and said, well, with our product, is it made in the UK? It
is. It's actually made in Northern Ireland.
It's made in the UK.
It is. It's made.
So it's a UK product. So straight away for me, it's a big win because it's like, if you're into politics and if you're into left or right, you're actually making a product in the UK.
Yeah, and we're really proud of that. The factory is in a great town called Portadown in Northern Ireland, just kind of southwest of Belfast. So
it's a British product.
It is.
It's actually, the cliche of anything made in the UK costs more than it's made in China. You're actually looking at bringing a product. You're making a product in the UK which is challenging people on price, and it's allowing you to drive your installation cost down.
Yeah, and I think it's crucial to think about the installation cost as a whole slate of work, right? It's not just the price of the unit. So again, some manufacturers may take more or less margin on the unit. What really makes your install costly right now is the work that goes into changing out the other components of the system. So we have to do a lot of radiator changes because you're running at a cooler temperature than a boiler does.
Bigger radiator.
Right. You need a bigger radiator to get the same amount of heat out from a lower water temperature within the radiator. For the water cylinder, you need a cylinder that is heat pump compatible when you're running at those lower temperatures because the coil inside has to be bigger, to account for the fact that you don't have the same temperature of water running through it.
So do your installs, do they all have cylinders?
Yeah, we do cylinders for every install.
So you do the buffer. So a lot of the techies out there will say, that's less efficient. You need to use a constant volume and flood the water. I understand why manufacturers obviously use the thermal store. I know some of the installers won't like what I'm about to say, but it's safety. It's a separation, isn't it? And at the end of the day, you don't know what's actually going on the end of it. I suppose if you have the time and effort to look at it, maybe that would work. But it's a completely different design altogether.
Yeah, so you can do a volumizer or a buffer. Often
get
you'll need that buffer.
So every installation, you get your new buffer, you get your new outdoor unit, you get the new controls.
Correct.
And if you need radiators, you will get new radiators.
Yeah. So our install price includes everything, all the labor, all the components. So that's all radiators, that's a new cylinder, that's your buffer or volumizer, depending on how it's plumbed in. It's all your controls, and all the cabling for power and control connections. So yeah, that price covers everything.
And the cost for a Cosy 6, again, I'm not going to hold you to it, but you're with your bus grant is around £5,000.
Yeah.
And you're looking at, as a company, you're looking at driving the prices down.
Absolutely.
That's
I mean, you can go back and look at the YouTube video of our founder and CEO, Greg Jackson, which happened just down the street here at the Wired conference in 2023 when we announced the Cosy 6. And he was very clear that our goal is to get that down to parity or less than a boiler without the effect.
So that wherever you sit, because the reason wherever you sit politically, whether you're in it for net zero or not, whether you think it's a waste of time, etc., you're a skeptic. If you're almost the same price as a gas boiler replacement, yeah, electricity costs more, but if you've got a special tariff, which I know you do with the heat pump tariff, which actually makes it more attractive, and you're using a more efficient product, you're almost putting the skeptics into a corner saying, well, why wouldn't you do it?
I think
there's still always going to be that small element if you've got a small property and you're going to do a like-for-like gas replacement boiler. You'll always struggle to compete with that. However, if we were to look at 20, 30 years' time where maybe a lot more properties will be on heat pumps, the way obviously adopting it is by getting that price right down, and it's efficient.
Exactly. I mean, to quote Bill Clinton from his political campaigns in the 90s, where he famously said, if you're explaining, you're losing. The best way to defeat the skeptics is to just build a better product at a better price so people choose it, right? If you don't have to explain to people that it's the better choice because it costs less, you can run it for less, it's greener, then it becomes the obvious choice, and you don't have to spend time explaining to people or trying to sort of defeat or shout down the skeptics about why it's a bad idea. It speaks for itself, and that's where we want to get.
That's I think Clinton might have been looking at Einstein, because Einstein said, I think if you have to explain it, you need to explain it. If you can't explain it to a 6-year-old, it's overcomplicated.
Yeah,
and in all
probably
fairness,
right. There's nothing new under the sun.
Well, heat pumps are a completely different industry to gas. I just want to go through one more thing with you, TJ. So, what does the Octopus journey look like? So, if I was to want a heat pump, what's the method? Is it an online application? Is it a phone call? Explain the journey.
Sure. The simplest form of the journey is that you would go to our website, and there's the ability to get an instant quote and pay a deposit to have a surveyor come to your home.
Okay.
We do charge a deposit, which is fully refundable up until the day before your installation. If you decide to cancel, you will get your deposit back.
Okay.
Now, if you're not comfortable maybe making that deposit or going forward just on the basis of that sort of web experience, you can always call and talk to our sales people beforehand. And many customers do. They have questions. They have concerns about making the switch from a boiler to a heat pump. And so they will call ahead of time. We're always happy to talk at length with.
So that's an online contact us.
Right.
Okay.
You can reach out to us, phone, email, or get a direct quote. A surveyor will come to your home, and this is...
Are they Octopus employed?
They are.
Okay.
They are. Everybody who will come to your home as part of this experience is an Octopus employee.
Okay.
The surveyor will come, and they will spend 2 to 3 hours doing a survey on your home.
Wow.
And that is to understand everything about your home in terms of the technical feasibility of installing a heat pump, because there are a number of sort of very technical and deep specification won't go into, even down to like the water pressure from your mains. But they also have to do the heat loss of the home, because that's how you size the heat pump. And we use the MCS method because MCS install standards are tied to the bus grant. It has to be an MCS install to get the bus grant. And we always want the customer to get that 7,500 pound grant that they're entitled to. We will do the survey. We will design the system and send you a final sales agreement that will list everything you're going to get, what your final price is. The price, unless there is something really, really sort of an edge case, which is, of course, always included in the fine print. But for the vast, vast majority of customers, that price you were quoted up front is the price you'll see after the survey. Right, so we give you that very clear indication at the beginning of what this is going to cost you.
Rather than you have the surveyor come out, you have a really good relationship with the surveyor, and then all of a sudden there's a zero on the price. And it's,
right.
So you actually give them a cost.
Correct.
And if all goes well, or there's no additions required, that is what you would pay.
Right.
Nice.
We want happy surprises, not unexpected disappointments, right?
And
like
the
you said,
and the
there's nothing
quote
like having that price double on you after a survey for any sort
it's
of
a brand killer.
technology.
It's a brand killer, isn't it? Because people
Yeah.
will talk. Octopus Energy Survey come out. This happened.
Yeah.
The cost has gone up. So, so that is that in the form of an email? Is that like an email PDF kind of?
Yeah, you'll get the
kind of
contract
document?
emailed to you, but the salesperson involved with that will also call you and talk to you about that and make sure that you're comfortable with everything, and we'll send you the final contract. And that contains all of the information about the components you'll be getting, what the installation covers, which I said is an end-to-end experience for all of the radiators and cylinder and controls and whatnot. It will also tell you any of the things that need to be done beforehand. So, there might be some changes you need to do to your home beforehand, which are often simple, like
client side.
Yeah, client side. For example, you might need to clear out this area so we have the space to put the heat pump, right?
Okay.
If you have something there, like,
Yeah, of course.
garden or flower pot,
or
yeah,
something.
that needs to be cleared out. So, and we have a customer operations team who can support you with that, as well as supporting you with any planning permission requirements needed, which are, of course, still a big impediment for heat pumps and for a lot of things that people want to do.
It's such a grey area. So us with our aircon, so we do 3 to 4 residential houses a day, and we don't put planning on any of them because we actually almost piggyback off the back of your permitted developments, which I think if you're under 600 meters, 6 meters, I think cubed, and you need to be at least a meter away from the property.
Yeah, both of those have just been announced that they're going to be taken away, which is great. They're going to remove the size restriction, and the 1 meter rule is going away, which is a huge improvement. Yeah.
So when's that happening? Do we know?
I can't remember off the top of my head when it will go into effect, but it just came out of the government consultation 2 or 3 weeks back.
Wow. So that is music to us aircon people's ears, because we've been doing it for years secretly anyway. Wow, that's really good to know. Because heat pumps are so quiet. That, the reality is I don't know what my saying has always been this. When a customer says to you how noisy it is, I say it's not noisy, but it makes a noise. So you have to put your ear out to hear it. And some of the manufacturers call it rustling leaves, but I've always said, well, how many leaves? If you've got 50 leaves rustling, it's a hell of a lot noisier than one.
Right. Yeah. I mean, I think probably the more honest characterization of it is it's about the same noise that you get from your refrigerator in your home.
Yeah.
Right. And I don't think anybody has ever walked through their kitchen and thought, I need to get rid of this thing.
Correct.
It's too noisy. Right. It is, which is sort of funny because, your refrigerator is a heat pump and
it's probably on propane.
Yeah. And it's
propane heat pumps.
it's one you've lived with for years. And, for me, and this may be a bit of a personal thing, I always find the discussion and the concern around noise a little bit odd because there are so many really unregulated and incredibly disruptive noise that we live with every day, right? How many delivery scooters do you hear go by that are so loud, right? There's so much other noise, especially, everything from internal combustion.
The noise,
so loud.
The noise, though, with the heat pump, whether it's an air-to-water or an or air-to-air, is it's something new. So we have to, and I'm sure you explain this to your installers, but it's a big deal. You're putting a box on the side of the house. This is a new thing. So I had a funny story a few years ago. We had a neighbour complain, and it was 3 meters away from the boundary, but they could see the unit. Oh, you can't put that there. It's going to be noisy. So there was a noise complaint issue. So I went to site and I stood underneath the aircon unit. Super quiet. You couldn't hear it.
Yeah.
And then what sort of was the money spinner was their boiler kicked in, and it was a combi boiler, and the noise from the flue was. And we looked.
I have said that to so many people.
It ended.
If you think a heat pump is loud, go listen for your neighbor's boiler when it fires up and hear the noise coming out of the flue.
It's the answer.
Right.
That's the answer.
Yeah. We are not living with silent heating now. It is, in fact, quite loud. And I think people look at a heat pump and think it's going to be noisy because they can see the fan. There's actually, interestingly, there was a study done about heat pump sound and perception, and it turned out that people believed the heat pump was louder if you made the fan white because they could see the fan spinning.
Wow.
And they believed it was louder. Right? So there's there's a whole human perception part of it, and I think there's this idea that our boilers are silent now, and they're not. You can hear your boiler running when you're in your home,
Correct.
And your neighbors can hear your boiler running when they're outside your home. So it is a mentality shift around the type of sound that you're going to be used to.
It's slowly changing though. So in the air-to-air space, it was always trying to tell customers, you do realise this unit you're using for cooling is really efficient in heating. And that's sometimes where the likes of social media and the internet is changing, because obviously we have air-to-water heating now. A lot more people are understanding it.
Yeah.
Rather than 5 years ago, the adoption rate was probably so low because it was so new.
Well, sure. I mean, if you were to go back 10 years, 15 years and look at people buying EVs, right? They were the weird ones. And EVs, there was so much skepticism. And now, I think this year, 1 out of every 4 cars in the UK sold is an EV.
Possibly,
right? So this is, there is always that sort of hockey stick shape of adoption and understanding.
But I personally don't compare EVs to heat pumps ever. I know they're both electrification. And the reason for that is especially if you're going down the Octopus route, because if you have an EV, the reason you went EV many years ago was, one, because you wanted to be electric and you wanted to cut your personal emissions. So that was one tick. The other one was because it was cheaper and there was less tax. But the tax thing has gone now, because unfortunately now the rate has gone up.
Yeah.
Whereas with heat pumps, as long as the electricity price now sustains and it is settled, and if you're using your own tariff, it's a different thing altogether, because you're not being taxed on you can't be, the only way you can be manipulated with a heat pump is with the cost of electricity. Whereas with an EV, unfortunately, you're paying for the electricity at a fixed price, but you've also got a tax implication. Unless it's a company car, and obviously the personal tax rate of the company car is obviously one hell of a lot less.
I mean, I think that is a fair characterization. One thing that we do find ourselves being concerned with in a general sense around heat pumps and electrification, and this is from the energy company perspective too, is that so many levies add cost to electricity on a unit rate. So about 10% of your price is green levies and other levies on electricity, which...
Can you explain that? Because I'm a bit green to that myself.
Yeah, so there are a number of taxes for renewable energy and sort of greening the system that are built into the electricity unit price that you're paying for every kilowatt hour of electricity that are not applied to gas, right? So we're making electricity pay for the fact that it is becoming cleaner every year, but gas gets a pass on all that, right? Gas just continues to be the dirty fuel that doesn't have these levies.
Is that levy a tax to the government, or is that levy a cost because it's going to the money from that is going to be used to create the energy of the future? Like, are we paying the price now for the better tomorrow, or is it just a tax?
We are in a sense paying the price for the better tomorrow, but it is a tax on the unit rate of electricity, right? And so if you're thinking, who do you want paying the price for the better tomorrow? Well, ideally, it would be the fossil fuels that have made the need for the better tomorrow so dire.
I see.
Right, with the world we're facing now. And the fact that you have a system in the UK where over 80% of the time, the electricity price is set by the price of gas because of the electricity mix and the influence that the gas providers, from a fossil fuel production sense have on the electricity system, right? So even as we electrify and all these levies are being paid, the gas system and gas providers are still profiting from the electricity system.
I'm with you.
So we would love to see some of those levies moved onto the gas side.
I don't know if you know about this. I think you probably do, but it's probably less energy. But the way the government are making a silent shift is, if you look at the gas boiler companies that make boilers, they have to invest into a certain amount electrification. Or they're being fined.
Yeah, the clean heat market mechanism.
Is that what it's called?
Yeah. I mean, I will be. So it was originally slated to take effect, I believe, in 2024. It's been moved to 2025, and for the first year, they'll only pay $500 instead of the $3,000 they were supposed to pay. So,
okay, so
we're glad that it has come back, because I think there was a moment where it looked pretty tenuous that it might go away. We're glad that it's there. I mean, speaking sort of personally and selfishly from a green perspective,
for sure,
I would have loved it to be sort of in full force earlier, right? Let's propel us.
That, for it to be kicked down the road, it's a bit of a. I think it's probably a bit of a kick in the teeth for the politicians, saying that we're looking at hitting our green targets, because they're not penalising the gas companies, right?
Yeah,
or they've kicked it down the road at least.
Yeah, it's been kicked down the road, and I think there's a lot of political reasons for that, right? We understand that there are many, many constituencies and many stakeholders and needs involved in any sort of policy decision like that. So, sure, net, I would have loved it to be immediate and sort of in full force. So I think now at this point we have to be fairly thankful that it will be a thing and that it will continue to motivate companies to innovate in the heat pump space and provide heat pump solutions that are better for consumers, that electrify the way we live our lives on a day-to-day basis and get us away from a dependence on a fuel that is both dirty from an environmental perspective, but is also not a native fuel for the UK, right? It creates this national security issue with dependency on foreign fuels. And the UK has this incredible wealth of wind power. There's no place on earth better to build offshore wind than the UK. Highest sustained offshore wind rates on average worldwide. So there is this opportunity to run the country on renewable electricity and deploy storage assets, grid scale batteries.
So that was interesting, TJ. So just closing, that's what I wanted to just discuss with you. So a good friend of mine owns a company called Solos Power. Big shout out to you, Paul. And he's one of the first, I think they're second in the UK. And this, you may know more about this than me, but the fundamental layman's term is the UK government would not back them. So the Korean government have backed them, and they're using Samsung batteries. So they've got 3 or 4 plants around the UK with thousands of battery storage. Please explain to me, because I see this as just mere stupidity, right? What he does is he buys electricity at night, and he sells it back to the government in the day, or he sells it back in the day. How does that work? Like, so during the night, he has explained to us that there's such an underuse during the night for obvious reasons. We're all sleeping, that the electricity almost gets put into the ground. So they harvest that electricity and then they sell it back during the day. So they buy it at a lower rate and they sell it back. I know this is, again, I'm not big in the energy game. This might be just common knowledge to you, but surely that, if you're saying about this wind power, surely charging these batteries charging them up and then use them during the day will help boost the grid, because obviously at the moment we haven't got enough. We haven't got enough power to power the heat pump. So that's a solution, right?
Absolutely. So when you look at how energy, and you can see this in the wholesale price of energy, it reflects the consumption on any given day. So there's sort of this morning peak where everybody gets up, you turn the kettle on, you turn the lights on.
Sure.
And then there's what we call sort of the midday trough where, everybody goes to offices and schools. So instead of each of us using our own light bulb, we're all sharing light bulbs and whatnot, right? And then we go home and you see that big evening peak where everybody's making dinner and they're running a bath for the kids and, watching television and doing the laundry and all these things. So there's big peak and then it drops off overnight because, of course, everybody goes to bed. And so the challenge that we have had over the years of renewables is, and everybody's familiar with these criticisms. Well, the sun isn't always shining, the wind isn't always blowing. And that's true. And so speaking about heat flexibility and flexibility in general, that is the core of flexibility, which is how do you generate at one time and consume at another time? And how do you shift usage around that sort of standard consumption curve, both as we electrify and also to reduce the peak. So the way energy is priced, it's always priced at the marginal cost of the last producing unit to come online.
I see.
So imagine it's sort of like an airline. Imagine if every seat were priced at the price of the most expensive seat that was bought on that plane, right? So you can't buy a cheap seat on that plane. Whatever the last price paid, which is going to be the highest because it's that person who bought an hour before the flight, everybody has to pay that, right?
Gotcha.
So if you stop those assets from coming online by deploying distributed storage, at grid scale, and you can use energy from batteries to reduce the peak demand. You can have people shift their demand, like with a heat pump, out of the peak period, heat the home ahead of time, heat it before and after rather than during the peak. You bring down that cost of electricity for everybody on the system because we're all paying the same rate.
I'm with you.
And so that is why things like your friend's enterprise work, because we need that storage, which provides a ton of services for the grid. One, obviously the storage part, right? You're banking energy. So when the wind's blowing and we have all this excess, you can store that. And then when you need that, you can provide it to the grid. But they also provide other things like frequency response to keep, you have to keep the grid frequency within a certain range. And so if an asset were to fall out or, an interconnector with Europe were to trip for some reason and supply would fall out, you have this instant ability to provide that frequency support to the grid. And we've done that as Octopus. We have our software platform, Kraken, manages a large fleet of distributed assets like that. And we had an event several months back where an interconnector with France tripped, and our Kraken system deployed a bunch of batteries instantly to prop up the frequency.
You're actually in that space.
Yeah. Flexibility is a huge part of what we do, because that is how the future energy system will come to pass, right? You have to think of the energy system in a whole different shape, if you will. We all grew up with this system where you generate electricity at some big centralized place, right? A gas plant or a coal plant or a nuclear plant, and the electricity, obviously it's alternating current, but we think of it in terms of it flows from generation to consumption, and that's it. And that people like you and me or businesses have always been viewed as just consumers, right? Now we are moving to a world where people like you and me and businesses are a part of the energy system, right? We are a participant. We change our demand, we change our usage patterns, but we can also generate with solar on our rooftops. We can dispatch from a battery in our home back to the grid. We can store energy in our battery and use it ourselves, right? So you're sort of self-generating in a way. You charge your battery from your solar panels. So everybody is going to participate in this system differently, and so what your friend's doing is a key part of what the energy system looks like in 5 years, 15 years, 20 years.
Gotcha. So he's obviously had the conversations with the right people and thought it was a good idea.
Yeah,
it's obviously great.
Sounds like.
TJ, thank you very much. It's been amazing to have you on. If you need to know anything else about Octopus Energy, we will put the link in below. Like and subscribe, and see you in the next one.
Thanks.
Thank you.